Hello and welcome. I thought I'd talk about Spark and Databricks and basically show some hands-on sort of usage of the technologies, talk about why you would use them, and walk through an example using both. So to jump right in, what is Spark? And we've talked a little bit about this in the past, but it is a distributed processing system. What that means is that it utilizes the concept of essentially a cluster, a collection of nodes working together, being orchestrated and essentially controlled by a managing node or a worker node or a driver node. That is, its job is to determine who does what. It doesn't actually handle the data itself. It tells each one of the worker nodes in the cluster, go get this data and do this operation to it. And then when you're done with it, somebody gets it back together and then it gets written somewhere. It is a good example of the concept of separating data from compute. There was a time that we stored our data on the same place that we did our processing. We've moved away from that, especially in the cloud world, in the big data world, to separate those two concepts from each other. This enables us to do things like turn off our compute when we don't need it and be able to still access our data potentially. So another interesting fact about Spark is it's up to 100 times faster than Mapreduce. That's going to depend on what's going on. It achieves that by keeping things in memory as much as it can. It doesn't mean that it's limited to only things that can be stored in memory. It can spill to disk, but in those situations where it can store stuff in memory, it is significantly faster than Mapreduce. The magic that makes it all happen are these resilient distributed data sets, or RDDs. They are the foundation for what makes Spark Spark. On top of data frame, or on top of RDD, is this concept of a data frame, very similar to like a pandas data frame. The benefit of using it over RDD is that you're able to basically say what you want to occur, not necessarily the low-level details that you have to do with RDD. That allows the optimizers and such to do things to make things much more performable. So RDDs enable the distributed processing. They keep track of lineage. They can be reproduced or recreated if something happens to one of the nodes in the cluster, so that maybe it is disconnected, or it has a hardware problem, or whatever it might be. It can be redone without having to redo the entire unit of work. Spark supports both structured streaming and batch processing loads. Structured streaming is slightly different than maybe a traditional streaming system, where the arrival of a data element is what triggers the processing. So if you're looking at something like a complex event processing system, or something like Storm, whenever something goes in to the thing that is being serviced, the queue, that is what causes processing to occur. Structured streaming uses the concept of a micro batch. So basically, the long-running process opens up every so often, goes and looks for something to do. If it finds it does it. Then it kind of goes back to sleep. So it's very much of a micro batch architecture versus the concepts of a true streaming system. But most of the time, it's good enough. So to install Spark inside of your Windows subsystem for Linux, which we've talked about before, you basically go to spark.apache.org, navigate to the downloads section, and copy that URL. So I'll show you that so that it's so we go to spark.apache.org and navigate. I think it'd be here, get started, and download the packages from the Spark website. That's here. So we want to download Spark, or you can click on this right here, and it'll take you to a mirror. So you don't actually download it from the place itself. So you're not necessarily downloading it here, but you're going to this place with a link to somebody that's kind enough to mirror the official distribution. What you want to do is copy that link address into your clipboard, and then we need to go over into Windows Terminal, and this is the preview version. I'm opening up my Ubuntu 18 shell and going into my home directory. And inside of here, I've already downloaded Spark, but if you do the wget-nc for no clobber, paste in that URL you just got. If life is good, it's basically not going to download it, but in this case it appears that it's going to. I'm not too sure what's different. Oh, it's a new version. Maybe is that it? Oh, I don't actually have it on this machine. So it is pulling it down as we're waiting. So once it's down, we'll do a few other things. So I'll shift back here. We've pretty much done everything except for this last bit. So we copied it, downloaded it. So this is going to be potentially a little more of a real demo than what I had really planned to do. So this should be fun. So it's 20 seconds or so and it'll be down. Once it's done, we're going to run tar-xvf, which basically says expand this stuff out into a series of directories representative of what's inside of that compressed tar. So tar-xvf Spark, and it's expanding it out for us. So really fast. And then we can go into the folder. Moving into the next thing. First thing you're going to want to do is go into the thing we just extracted into bin. It is Spark. Oh, I'm already in there. Bin. And then we're basically going to if we want to run Scala, you basically use /spark-shell. So a key thing about Spark is that it allows you to use whatever language you are most comfortable with. So if you're a Scala sort of person, you can use Scala. If you're a Python person, you can do PySpark, which is basically Python linked into Spark. Or you can do SQL or R if you like R. So there's Spark R as well. But what we'll show here is just Scala. So the thing I need to do now is get some data onto this machine. So I'm going to go over to a data folder, copy the Fortune 500 listing, and I'm actually going to shorten that up because it's kind of long name, so we'll just go Fortune 500 to make things a little easier. I'm hitting Control-C, and I'm going to cheat. And this is actually one of the really cool things with WSL 2. You can see I'm navigating inside of here. This is the hard drive, essentially, of that machine that we're on. It's essentially a virtual machine. Going down into, I'm going to just put it into my home folder here. So there it is. And then if we switch back here, if I do, I'd have to exit out of this. I'll do that just so, is it quit? All right, Control-C it is then. All right, so if I do a ls, and I have to go up a couple levels, you can see that Fortune 500.csv is there because I copied it over from my Windows to my Linux drive using Windows Explorer, Windows File Explorer. So pretty cool stuff. So back into the Spark shell. So then we basically are going to read that file. Since I am, oops, I want to copy it, so I'm going to stop the slideshow and make it bigger. Get back on the right slide. Since I changed the name of the file, I'll need to change this. I'm going to just copy the first bit, paste it in, and I called it Fortune 500.csv. And so breaking down what this command is doing, inside of Scala you create a variable using the val command. So it's val and df, so I'm creating a variable named dataframe, and I'm assigning it equal to the value of whatever comes back from spark.read.format, and that's CSV, so I'm saying I'm reading something that is in CSV format. It does have a header, and then I say load it from this file. So if I didn't mistype anything, we'll get back a data frame. So a data frame is, like I mentioned, a layer of abstraction above an RDD. You can get to the RDDs if you're so inclined. You're probably better off not. If you want to see what's inside of that data frame, you just do df.show, and it will print it out. Not exactly the most beautiful thing you'll ever see. I can make it look a little better by making it bigger, but it's kind of wrapping. So you can also, though, do df.select and then give it something we want to select. Similar to what you're doing, it's essentially projection. Name, all uppercase. And so we can see just the list of 20 things, the first 20 things inside of that data frame. The next step might be to be able to do some simple analysis. So we'll start off with this, which is doing an order by profit and descending, so the things with the highest profit, limiting that to the first 20, and then I want to show just name and profit. So another thing, and this is where I kind of probably made this a little harder than it needs to be. Revenue is what we probably really care about, right? So if we switch this to revenues, and group it by revenues, and order it by revenues, and select revenues, we can see this. And we may want to go ahead and do one last thing, which is rank, which not surprisingly is the revenues and you can see it in ascending rank as well. Or you may just want to order it by rank. So interestingly enough, that's doing a string ranking, and also it looks like that might be a string sorting on revenues as well. So probably would be worth doing some data type conversion if we were doing this for real. You can also tell it to infer the schema, not something we're doing here. So to try that, and this is when it always goes badly whenever I'm ad-libbing. Should be this. And then if we do that, revenues descending, you can see that it's now doing it correctly and ordering things by the actual revenue. So Walmart, not surprisingly, is number one with the highest number of revenue. So that's basically using Scala to load data and do some simple reporting on it. Moving over to the next part is doing the same thing, but this time using PySpark. So I want to say it's exit or quit. Anyway. All right, so to do PySpark, not surprising, it's PySpark. You do have to do the // most of the time, likely because the current directory is not necessarily in the path by default. So doing a similar approach, the format is very similar, except subtle differences here and there because it is Python. And I'll go ahead and, just to save some time, lowercase infer schema. And then a show, same sort of things. And then the query is a little bit different whenever we do it because it's Python. So to walk through what that's doing, we're saying order it, so that means arrange it so that it comes back in the order of a profit in a descending fashion, limiting to the first 20 and showing name and profit out of that. And then we can also switch it to where it does it off of rank. It doesn't look like it necessarily inferred the schema very well. So, is that going to work? Yeah, so you can see everything is a string, so it did not infer the schema correctly. Probably I messed up something in the way I typed it. Not sure what I did wrong, but anyway. So that is Python. The last one we'll go through here is Spark. Spark SQL. So similar concept, /Spark SQL. And Spark SQL is, like the name probably makes you think, it's an implementation that lets you write SQL statements that are basically running Spark jobs. So you can think of it as being very similar in nature to Hive. One of the differences here, we don't necessarily load a data frame, but instead we create a temporary view onto the file that we have. And I wonder if I can say infer schema true. And then you always have to end them with a semicolon, which I generally forget. Let's not deviate too far from the script. So going back, and then again the semicolon. So what's it not liking? Oh, I mixed up my things, and that's probably what was wrong on the one before. So go ahead and put the semicolon and change this to a single quote. It's got to be, they've got to match. All right, what's wrong with it? CVS, that's what's wrong with it. The dyslexic messing up things. All right, and then we can do describe companies. And looks like it didn't necessarily do it well either, and it didn't also, that's why. I didn't do the header. Right. Whenever it's doing, its header is true, so header true. And you can do create or replace. And this time it actually worked correctly, so that's probably what was wrong also on the other. The way that infer schema works is it actually does essentially a sampling of your data and figures out if everything looks like a double, then it's a double. Everything looks like a string, it's a string, and so on. If you have something like a string in the first row and you don't tell it to skip over that, or that is actually important because it's your header, it throws off its inferring of the schema. So that was what was wrong on the Scala or the PySpark version of it, is I forgot to add that. So now that we've got a table, we can do our good old select star from companies. Always remember the semicolon because it's going to make you do it, and then to do this particular one, we can basically say select name, rank, revenues, profit from companies, order by rank. And if I typed it all correctly, and then you want to limit it, so say limit to 20. And if it is clear, nope. So trying to get it to where you can see the distinction. Not quite as pretty as you might like, but you can get an idea of the values. So very, very useful sort of tool, and so on. So now we'll do something similar by going back and talking a little bit about Databricks. So we've talked about what Spark is, and we've ran some queries locally. So what is Databricks? And it's a company that was created around 2013 by the people that initially created Spark. Spark is an open source project, so there's lots of authors in Spark, but there were a group of people that created it to start. They saw that they had something good, so they took it to be a commercial venture. It is a cloud-based product, so whenever it was launched, they saw that the cloud computing paradigm was the future, so that's what they targeted. It is available on Azure, AWS, and GCP, so it is on the three major cloud platforms. It enables you to do notebook-based development, so very similar in nature to something you do inside of Jupyter, but makes it a whole lot easier. Plus, it does the support of the four languages we just talked about: Python, Scala, R, and SQL. And the biggest value in a lot of ways that it brings to the table, it is in drop dead easy to create clusters. So to be able to create them, manage them, have high degrees of security, integration with various cloud offerings, and an emerging set of tools makes it a compelling sort of set of tools. It is viewed as a cloud analytics platform as much as it is just Spark. Spark is the engine, but there is more to it. You can do integration with Git repositories, and it is their primary revenue model is all about consumption. So they've got an incentive to keep making the product better. What does it look like? Like a web application of sorts. So this is pretty much what the home page looks like. We'll take a look at it here in a minute. You get there by going to community.cloud.databricks.com, and it is free. You don't have to sign up. It is something that lets you do. There are some limits to it. It's great for learning, but you can only create one single node cluster at a time. So that means there's basically the combination of a driver and worker together. So there's only one driver and one that's also the worker. So it's not necessarily going to be a real solution for big workloads. There's some additional functionality that may not be available because it is a shared environment, so they will do things to sometimes lock down the security a bit. But it is quite useful, especially for potentially doing an assignment. Here's an example of, I uploaded a CSV from data.gov and basically created a notebook, and the result could be a permanent table. We'll walk through that process in a moment. Cool thing with the visualization and the results that come back from your queries or your instructions is you can look at them as a grid like you see in the top. You can also do some simple visualizations as you see in the bottom. So you can upload data, and this is probably a great time to shift over and start doing that. So going over to Databricks Community Edition, I've already signed up and logged in. And I actually cheated a little bit and went ahead and kicked off a cluster because it can take a bit. So I'm going to go ahead and delete the one that's not running just because it'll cause me grief at some point if I don't. And there's a single node running. And so when you land on the home page, pretty much everything you need is kind of shown to you in one go. Your common tasks are listed underneath of the heading common tasks. They include things like creating a notebook, creating a table, creating a cluster, and then some more quasi-advanced things like an MLflow experiment. MLflow, pretty cool technology, especially from a machine learning perspective. It allows you to keep track of various runs of your notebooks and determine which one is best, save a model to a repository, and then deploy the best model, if you will, to production, all from pretty much 1 or 2 lines of code. So really cool stuff. The recents is kind of like your recents in a lot of applications. It's the things you've worked on recently. And then the last is just what's new in the particular version of the community edition. Also across the top, there's some 3 sort of things. And it's one of the reoccurring themes you'll see inside of Databricks is there's lots of ways of doing the same stuff. So over here is the menu. You can, it auto expands and contracts by default. So you basically mouse into it and it gets bigger, showing you what they are, and it shows you the abbreviated version. Otherwise, a workspace is kind of like a file system, right? It's the things that I've uploaded before and used and so on. You can share it in certain environments, not necessarily in the community edition, but if you have it in a cloud environment like GCP or AWS, you can have, depending upon what you configure, you can have it to where you can have people accessing your directory, or you can access theirs. You have control over it. You can determine who does what. Also, there's the concept of a shared environment so that you can put things into a location for common usage. So that's kind of at a high level what that looks like. There's also relatively recently they've started adding an additional set of functionality based upon workload. What you'll be doing for what we're looking at today is pretty much data science and engineering. There's also machine learning workload, which has an auto ML feature that's really cool. It'll auto generate a notebook for you that basically, or a series of notebooks that basically lets you see what they did to achieve whatever value it is that you're trying to minimize or maximize. So pretty cool. So a glass box approach to data science, auto ML. The data tab lets you see tables inside of the database. A database is basically a schema in this world. If you think of traditional databases, so if you've got a SQL server running, you have multiple schemas inside of that one server. It's kind of that sort of concept. You can go and create databases it doesn't look like you can in the cloud edition. So you do have a default database. Inside of the database, you have tables that you can essentially interact with, very much like a traditional table. So back to the task at hand, which is we've got this Fortune 500 file that we want to upload. So all you have to do is really easy. Just drag it and drop it onto this thing that says drop files or click to browse. So you can drop a file there, it uploads it for you, and you have a choice here of either creating it with a UI or in a notebook. We're going to do a notebook because I want to do some other stuff. They create this notebook for you. They give you the indication that this is a Python notebook by default. You can see it up here. You can actually change it if you wanted to something else. But generally speaking, you want the majority of your cells to be in the default language. It's just one of the things we do. But you can also do some magic commands that let you switch between the languages on the fly. So we uploaded the file. Apparently, I've uploaded the Fortune 500 several times in the past because in the file store there's 8 versions of it. It is a CSV. We do want to infer schema, and it does have a header in the first row. And so this is basically written the Python for us that loads that CSV into a data frame using the separator and of the file type. Very, very similar to what we did before. And I'll go ahead and run that. We have to attach to the cluster before we can. So I'm going ahead and attaching and running. And so at this point, it's actually loading that file into the data frame and showing it to us. One of the key things to understand with Spark in general is that it does lazy evaluation. So if you don't call that display df, all you've really done is tell Spark that at some point you're probably going to want it to load that file. So it actually gets loaded at the point that it's needed to satisfy the request that came in. So the next thing to do is to create a temp table name for it. And we'll go ahead and call this Fortune 500 temp. And I'm just doing that so that I don't have a collision or something later on. And then you can select from it, and we don't necessarily need the little backward ticks because I did make it to where it's nothing really special, those spaces or anything in the name. What I'm doing to run the command is holding down the shift key and hitting enter. There's also a handy little diagram here or example here that comes up and tells you what to do. So if you want to go to the command mode, if you want to go into editing mode, and so on, shift and enter will run and move you down to the next cell. Control enter just runs it, leaves you in the same cell, and so on. There's quite a few of these sort of functions. One of the ones that I found myself using recently was find and replace inside of a notebook, which was very handy because I had to change a bunch of stuff. So here we can see we just ran a SQL statement here by using %SQL as the magic string that says that what's inside of this cell is SQL. And so from that point on, we can just write SQL inside of that cell. Back here, we switch over back to Python. If you wanted to say this is a permanent table, you would uncomment this line, probably change this name to something more meaningful, and so on. So the next step is to run those same commands that we did earlier. So here, this is just walking through talking about the things that we just needed to update, give it a shorter name, and so on. And here's what we're going to produce in a moment. So the key piece is right here inside of Scala, and to do something similar to what we did before. And I have to change this to be 7, or is it 8? 8. And so what this is going to do is it does have a header, and we want to go ahead and add Infer Schema. And so I don't have to do it again. I'm going to go ahead and put that in here. And we'll run this. I probably should have ran it first to see if it actually works, right? And so here we have converted into, so it's actually doing values because we are inferring the schema, and then we're running a display command to basically show us the schema of the data frame that we just inferred. And that still looks a little off. Oh, but that's off of profit. So if we switch this over to rank and order it by rank, and I probably should do that in a separate line, and we probably want that to be ascending and not descending, because you want to start with number 1. So we should see Walmart as the first one. And there we are. Moving down to the Python version. And because we are in a Python notebook, we don't have to include the Python magic string. And here we do want to add, there is a header. We also would like to, for schema, and then show them by profit. So Apple was the most profitable. And then moving on to the last bit here of SQL, which we don't, well, we do need that because we've already created this temporary table name up here. So we just need to select from it. And it's already done the inferring of schema. Need to plug up a device before I lose power. So that's Databricks running through the same basic thing that we ran through at a command line. As you can see, similar results to what we just saw. So thinking about this from a big data perspective, it is one of the more popular, if not the most popular, big data framework in use today. And it is very popular because it is very easy, and it being Spark, not necessarily Databricks, it being very easy to use and to produce big data jobs without having to do code in like Java. It's partly gaining increasing of usage because of the challenges with Hadoop and Mapreduce. A lot of effort was done over the years to try to get Hadoop and Mapreduce to address some of the challenges. A key challenge is iterative processing. Mapreduce can't really do it, and it wasn't really meant to do it. The reason being, it was originally created to essentially process log files. That's kind of why it came to be in the beginning. And the idea in general with Mapreduce is it is a single pass through. It's not something that's intended to have multiple iterations running. So iteration is not something that's natural for it to do. And that's one of those challenges with it. And lots of work was done to try to extend it. It just didn't really work out well. That's not to say Hadoop is not still a viable platform with lots of usage, and Spark is part of the Apache umbrella, and it works with Hadoop. You can actually run it inside of a Hadoop cluster. It can access HDFS, so the Hadoop file system, and so on. In order to use Mapreduce and Hadoop, depending upon how you've got things configured, you typically have to have the cluster up and running. There's also some pricing challenges even in the cloud for Hadoop clusters. Example being, if you use Azure's HD Insight, which is HD Insight or Hadoop in the cloud, you pay as long as it exists. So it doesn't matter if it's on or not. If you just have it provisioned and it's sitting in your subscription, you pay the same price as if it's running at 100% utilization. Not too long ago, Cloudera purchased Hortonworks, and one of the things that it seemed happened pretty quickly thereafter was all of the Hortonworks versions kind of stopped being produced. And Hortonworks used to be a fairly vanilla version of Hadoop. It was pretty close to the Apache distribution. Cloudera has got a lot of customizations on top of it, but it also has a higher price tag. And because of that, a lot of companies that were previously under Hortonworks are now forced with the choice of staying with something that's pretty dated or upgrading to Cloudera at a much higher price point than what they were used to with Hortonworks. And because of that, a lot of people have decided maybe it's time to get off of Hortonworks or off of Hadoop and onto something else. Data lake architectures, and in particular, Databricks' lakehouse architecture, is an emerging and a very attractive paradigm that a lot of companies are moving to. The idea being that it's much cheaper to store your data in a data lake. You can have security on top of it, and you can access it from a technology that's pretty much independent of the storage. And it happens that Databricks and Spark are a great way to process things that are stored in a data lake. Inside of Spark and Databricks both, you can pretty much access anything you need to access from a data perspective, especially from a big data perspective. You can connect to relational databases if for some reason you need to retrieve stuff, though it's not an ideal way of doing things other than if that's just what you have to do. The better approach would be to reevaluate why that data isn't in your data lake to start. So that's more of an architectural sort of conversation. You can also, as I mentioned, do both streaming and batch processing in the same framework, possibly very, very similar to the same code. There's some differences, but not tremendously different. And there are some performance implications that go with those as well. So the lakehouse architecture relies heavily on the concept of structured streaming and using it as a means of creating essentially your refined and your aggregate values quickly. So rather than doing a bunch of batch processing, whenever something changes and it gets merged in, the changes will trickle through the environment in a very controlled way. If you think about Databricks and Spark from a database perspective, it is and it isn't like a database. It is in the sense that they both store data, but it's not intended for something that's essentially transaction processing. So not a great idea to try to do something that has low latency sort of requirements. You might get there, but it's not exactly the sweet spot. You can think of it because you are writing SQL that it might be a way of doing a lot of the processing that traditionally has been done inside of a database. And the fact that most people that know SQL can be productive quickly inside of both Spark and Databricks is a very compelling argument for using the environments. There are the concepts of tables, but they need not necessarily be relational inside of Databricks or Spark. Also, you can have basically objects stored inside of what are essentially columns inside of your tables inside of Spark and Databricks. So that means that you can have literally a map object that corresponds to a dictionary in, say, Python, stored in a column in your Databricks tables, and be able to access the values that are stored inside of that without having to pull them out. So it uses a dot notation, so you would do something like select star from, or select the column dot to the value that you're interested in inside of that column to project it out if for some reason you want to get it. And you could also do so on the where clause. So the compelling thing about it is anybody that knows SQL can be quite productive quickly in Databricks. And with that, I've reached the end of my material. As always, if you have questions, let me know. I'd love to hear them and answer them. And as always, stay safe, and we'll speak again soon.